Sam and I, we have a lot in common. He's with RedZone, Robotics, and I'm with Hitachi Data Systems, and one of our larger divisions is Robotics.
Thank you.
So our last speaker today is going to talk about Robot Pipe Dreams Come True, the new digital underground. With us today is only Sam Cancilla. His counterpart, Matt, is not here, so I will turn the mic over to you.
Thank you. Thanks, everybody. So, again, the name is Robot Pipe Dreams, and it's kind of cool we get to play with robots all day. How cool is that every day? So we're located right up here at the street, not too far away, and the reason why we make this is really this. I don't know if you can see this or not. There's actually a woman sitting in a car. Here's a sinkhole. I'm sure you see these in the news a lot, and the question is, how does this happen? Well, there's signs in the pipe when there's defects that turns to a small crack, to a larger crack, to a hole, to a sinkhole, and when this happens, it's on CNN. So it's kind of too late. So what we do is we have robots to go underground, like right now as we speak, in this area, there's robots traversing the pipes, inspecting, taking all kind of data sets to try to get to these predictive models to stop this. So a little bit, we're a spinoff from Carnegie Mellon, been around for over 25 years. We're strictly water, wastewater right now. The nuclear side kind of dried up a few years ago, so we're strictly in wastewater. We're headquarters right up here in Lawrenceville, not too far from the NREC. We're right by the river. And we also have an office other side of the world in Auckland, New Zealand. So kind of nice, we kind of do data sun up, sun down. And we're kind of recognized as innovators in the industry. So we actually create these products here in Pittsburgh that are used throughout the world. Little timeline, just kind of give you an idea. We really, the name RedZone came from the danger zone. It was a spinoff from 3 Mile Island. They made the first robots that went into the reactors to do some inspection and cleanup. Again, the past history was all nuclear. Really about 2002 or 3 is when the company switched over to the wastewater. And you can see since some of the things that had happened during those times. We've been involved with some autonomous driving. Again, we have autonomous robots that go through the pipe. Kind of give you an idea of the sampling data set. We've had our systems in over 200 major cities throughout North America. I mean, here's a sampling of some of them, some of the largest cities. So again, we're collecting millions and millions of feet of data underground. And when you think about it, I'm sure all of us have seen one of the Google cars driving around. You see these funny cars with these masks. And actually, in our building, I don't know if you've seen the news or not, but Uber just started an autonomous driving program right next door to us, where they're starting to go through mapping out the city. But what these units are doing, they're actually collecting massive amounts of data, right, above ground. So we're doing the same thing basically below ground. We call it the underground infrastructure, right? So we're actually mapping, while the Google cars are driving around mapping all the upper areas, we're actually doing everything below ground inside the pipes. And we all play a role in this. Every day we go out and wash our hands, take a shower, flush the toilet. Well, that water goes somewhere. It goes down pipes, down to your laterals, down to main lines, down to these pipes under the ground. So we all play a role in the system. Eventually we're going to get to the day where we have like Google Pipes. Right now we have Google Earth View. Well, you can type an address in and go to a location here at the Marriott. But the next question is, what's underground? I mean, there is, besides wastewater, there's water, there's gas, there's all kind of utilities under there. Can you imagine how much money is being spent? Billions and billions of dollars is being spent every day trying to maintain the infrastructure. So again, taking some of the technology that's being used above ground, below ground. Again, we're using panospheric cameras, lasers, LiDAR systems, gas. It's kind of like going into the pipe and playing the old Pac-Man games. If you remember back to the Pac-Man, the little Pac-Man going through the pipe navigating, we're doing the same thing underground. I mean, so we're taking these robots, going out and mapping out whole entire cities all throughout North America. A few years ago, even the White House came in. If you can hit the link here. Just to kind of, because they realize we can't afford to fix our infrastructure. Asset management is the buzzword.
From a local company, RedZone Robotics, who make robots that explore water and sewer pipes. And I have to say, it's fascinating stuff. When you watch the robots about this big, it can go through any sewer system. It's operated remotely by the municipal worker. It's got a camera attached so it can film everything that it's seeing. It then transmits the data that goes into a citywide database and can enhance the productivity of these workers by 3- or 4-fold and help the city make even better decisions. Potentially, this can save cities millions in infrastructure costs. The company is also training new workers to operate the robots and analysts to pore through the data that's being collected. And I just met with folks from a local company, RedZone Robotics, who make robots that explore water and sewer.
It's $1 billion fix to maintain our system, billions of dollars. So it's all about prioritizing and finding out which pipes need to be fixed and maintained. So just kind of give you an idea, we're talking $300 billion. Our infrastructure right now is a D. That was 2013. It's a D minus now. It's getting older and worse condition. So how do we maintain that infrastructure? There's no way we can afford to replace it all. It's impossible. So asset management is really comes down to, this is the EPA, understanding what do I own, where is it, what's its condition, what's its useful life, and what's its value, right? So again, when we buy a house, we get a home inspection. When we get a car, we get a Carfax. But yet our infrastructure is the model we use right now is run to failure, right? Which is a horrible model. The other problem is the workforce. You know, within the next 5 to 10 years, almost 60% of the folks in the industry are going to be retiring that have a lot of this knowledge. So it's even more important to take all that data now, put it into an electronic form that can be used for the next generation. Again, these pipes have been in ground for over 100 years. You know, right now as we speak, there are these robots going through the pipe right here in downtown Pittsburgh, but also clear across to California. Again, they've outlived their life. I mean, they've been in ground for many, many years. So we got to rank and prioritize what's going on.
Do you see an application someday with things like oil pipes?
Absolutely, yeah. Again, the other thing is the folks have been here for 30, 40 years of retiring. They're taking that knowledge with them. So we take that data now and actually put it into software that allows you to, again, we manufacture all this equipment here locally that's used globally. It goes into these web-based programs that allows the cities to make all these $1 million decisions of which pipes to fix. We actually have a program called Your Entire System where we go out and do whole entire cities and map this. I mean, here's an idea, or a sampling of what we do. Just kind of give you an idea. And again, right now we have robots in over 2,000 miles of pipe. So think about that. That's going from here to Las Vegas of data. It's a massive amount of data. So how do you actually do that? So the software we use can scroll through all that data. And how do we do it? We have these autonomous robots. So these little solo robots, they're about this big. That's what the president was talking about. You put them inside the pipe and you hit go, and it goes through the pipe by itself, collects data, comes back, and then stores it. So you see these big, massive trucks out in the street. Well, these little robots, this is more of a joke. You can put them on the back of Harleys, SUVs, minivans. It doesn't matter. It allows you to be very portable now. Plus, you're not disrupting traffic. You're not making a lot of noise. So it allows very quickly. Right now, these robots are underground here locally. Nobody even knows they're underground because there's no truck. The manholes are closed. You drop them in, come back, pick them up, and then code the data. So again, what's nice about it, you have 1 or 2 people now can hand carry these to remote areas. Pittsburgh here, we have hills, rivers, a lot of terrain, very tough to get to. So these robots are very mobile. You can go into these unique locations. Just kind of give you an idea, the EPA has these things called consent orders, which are multi-million or billion dollars. We're actually under one right here in Pittsburgh. It's a $2 to $3 billion deal. This technology now allows you to go through the pipes very quickly, very efficiently, and cost effectively. To give you an idea, we had to do a project recently in the other part of the state. They had to get 100 miles of inspection done in 90 days. They ran the models. It would take them 25 years to do that with their current technology. We did it in 90 days. So that kind of gives you an idea of how the technology can speed to access. Once we get it in, it's kind of like Google. We have technicians right up here in Lawrenceville that process data all over America. It goes into these reports, into these pipeline analysis tools that comes down to these platforms that collect all this multi-sensor data. So these are other tools we manufacture here. We're collecting video, laser, sonar, gas, all kind of information. It's kind of like when you go to the doctor, right? He gives you a physical, but if something needs to be evaluated, he gives you an x-ray. If he needs something more in-depth, he gives you an MRI. So we're actually thinking of it like we're MRIing the pipes underground. We're able to go through with this technology, figure out the geometry, the corrosion, the wall loss, the debris, what's the condition of it. and make sense of it. You know, I show this here because, and it really comes down to qualitative data or interpreting it. If you look at this train, you know, and your brain can play tricks on you, some people see the train coming into the tunnel, and other folks can see it coming out of the tunnel. If you think about it, it can go either way in your brain. Right? So, again, if you're evaluating a pipe and you're making a wrong decision, right, is this train going to you or against it? We can sit here all day and debate that. Well, if I had a sensor on there, it would tell me the speed of the train, the direction of the train. I can get a lot of information without guessing. So, again, our eyes sometimes play tricks on us. Underground, it's $1 million mistake because it leads to a sinkhole. So what I mean by that, if you're looking at a concrete pipe inside of a pipe, if you look at pipe A or pipe B, nothing really pops up. Well, pipe A, actually, there's only about 8% corrosion. Pipe B, in this location here, there's 90% of the pipe wall is gone. That pipe's going to fail sooner than pipe A. So we take that data, put it into reports, video, files, and heat maps that you can see. Red is bad, green is good, where all your defects are located in your pipe. And we do this for millions and millions of feet of pipe. Again, kind of like going to the doctor underground. Again, we just did a big project for the city of Harrisburg. You know, they haven't looked at their pipes in forever. You know, they needed to understand what the condition of the pipes. They're failing, they're getting sinkholes. So again, using this technology allowed them to go out and actually build a pretty good roadmap. So again, these systems, as we speak right now, are right here in downtown Pittsburgh, but also being used globally. And again, we're getting video, laser, sonar, gas, all in service. I mean, locally in Alcosan here, we're talking about $3 billion. I mean, think about that. That's got to be one of the, you know, major impacts to the county. I mean, that affects all of us, right? Because it affects your taxes, that affects construction. This is going to be this is not going away. So the question is, how do you maintain a system? Again, every time we flush the toilet, take a shower, use the water, it's got to go somewhere. So this $3 billion consent order is really the tip of the iceberg. I mean, this is going on all throughout America. Cost savings, the technology we're using, one of our clients is the city of Fort Worth down in Dallas. By using some of the technology, they're saving millions of dollars by ranking and prioritizing which pipes need to be fixed, repaired, or replaced. And we find out over the millions and millions of feet of pipe we have, you know, only about 20% right now need some immediate action. So the whole goal is to go through and find that 20%. Because a lot of folks, they're probably fixing the wrong percentage. They're working on pipes that are in that 80% that are good and not even getting to that 20%. So the whole goal is to find that 20%, spend the money wisely. We use software that goes into that. Again, the software we're using is web-based software as a service. So all the data comes in the Pittsburgh here and gets spread throughout the country that we distribute it. So it comes up to these online Esri GIS maps that rank your good, fair, and poor pipe, kind of yellow, green, red. It brings up their system of record, so all their data is stored locally now. So for the next generation, when they want to click on the video, if they want to do a search, show me all of my 10-inch pipes in the city of Pittsburgh that have a crack greater than 3 inches. It pulls it up onto a map, onto a spreadsheet. They go back to the video. They can go look at it, make a recommendation, get the pipe fixed, and then it goes into their asset management program. So again, the whole thing comes down to, you know, we call it a conventional approach or RedZone, but really what it is you're either proactive or reactive. You're either putting out fires or you're trying to prevent them. So the technology is really geared towards preventing fires. It's really taking the information and making it useful. Am I on time? Okay, good. Yeah, questions?
So, Sam, how do you, or where do you store this data?
So,
Because I'm in the data storage.
yeah. So everything we do, we have local storage that we use, but we also, our clients, we put everything on hard drives and they store on their servers. So again, it gets into a game of who's going to store the data. We always replicate a copy of it, but a lot of our clients actually have their own copy too. It's getting to the data set where they can't manage it now. We're starting to bring in third-party firms to do that. Yeah, yep. Yeah, on our board we have Jack Young is the founder of IBM Maximo. Maximo is one of the larger asset management programs. We're also an Oracle-based business partner. So, yes?
What kind of technology are you using to transfer data off the initial inspection robot devices?
Yeah, so the way the robot works is, think of it like your camera phone. When you come in, we download the information, it comes in electronically, and we use a format that's called PACP. It's a rating system, 1 through 5, of how you grade pipes. It's a universal rating system to code pipe. From there, it goes into the software.
Yeah, I don't like Ethernet or Wi-Fi.
Oh yeah, well, we have both. So we have Wi-Fi from the robot to the tablet we use, but then it goes to a hard drive to an Ethernet connection to download it.
Are you collecting that data as the robot is underground, or is the robot recording information that you download that after you retrieve the robot?
Both. It's recording it on board, and then we actually post-process it afterwards. But we also have live systems that go in and collect it as it's going.
Do you like do a cost-saving share? What's the business model?
Yeah, so I mean, the business model is, again, we're manufacturers and also service providers. So we deal with a lot with cities directly, engineering consultants. Yeah, more service-based, yeah. More questions? Yeah.
Yeah, I guess how often would you say is the case that in order to effect a repair, you have to tear up the street?
Yeah, we see on average about 20% of every pipe we go into has a defect that needs to be repaired. You know, but what we see, people spend money every day and they're probably fixing the wrong pipes because they just don't go through and get it inspected. They wait till something fails. Well, when it fails, it's kind of too late. Yes.
How autonomous are these robots? How much operator interaction is?
Well, what's nice about it is there's very little. I mean, so these robots, they're autonomous, but they're actually tethered. I mean, so think of it like a long leash. We make sure they come back. Some of them are fiber optic controlled. So that's the whole goal, is try to take the human element out of it. It's collect all the data on board and then bring it back to do all the processing. More questions? Yes?
So, how do the robots know where to go? Are the pipes pre-mapped? Like a robot comes to a junction, and then how does it know to turn?
Well, it's a good question. So the question is, how do the robots know where to go? So we work a lot of times off GIS. Some of our folks have everything mapped out in GIS. So we get what's called shape files. They're actually known points that they're pre-programmed to the robot. Kind of like, think of the contact list on your phone. So they're already pre-programmed. They get a GPS point to confirm they're in that exact location, and then they'll go from one side to the other side.
Okay, well then the other thing is, I thought GPS technology talked to satellites, and the robot is underground. So isn't it locked with talking to satellites?
It is.
I'm sure there's something I don't know.
Yeah, so GPS does not work underground. It'll work right at they're called manholes where you put the robots into. Once it's underground, it loses the GPS signal. Now, we have technology that actually maps out underground as it's going through, but we get a GPS of the entry point and the exit point, and then we tie that together through the map.
Out of curiosity, what's the size of the fleet for a cluster? How many robots do you deploy at once?
So that's a good question. Yeah, so what we do is we actually, on the solos, we call them a squad. And like right now, we're up in Battle Creek, Michigan with these. And we got a crew of, I passed it up here, there's probably about 20 going on as we speak. So a few guys can deploy multiples. Normally about 4 of them they put in the pipe. I can't find this slide here, but there it is. So what's nice is you can put in 2 robots, one direction, close the manhole, put 2 more in, close the manhole. So what's nice is the crew, they'll put in 4 or 5 robots, go to lunch, and come back, and they just had all those pipes inspected while they were eating, because they're not sitting there controlling them.
So my question was really towards what kind of data size are you looking at?
Well,
20 robots.
yeah, we're collecting anywhere from, we go by footages, anywhere from 5,000 to 10,000 feet per day. Most conventional equipments probably give you about maybe 500 feet to 1,000 feet a day. So we're getting 5-10x daily production.
What does that commercially look like?
It depends on the file size and what we're using. But, I mean, we're talking, we probably, on a typical city, you're probably talking about 3 terabytes of data. Any other questions?
You ever use them for archaeology?
Well, Not per se, but we do a lot of work down in Washington D.C. into some secure areas, you know, that we can't get the data to only certain folks. So, but they're more secure areas than archaeological areas.
I guess some of these pipes haven't been inspected visually for a very long time.
Some forever. I mean, there's some folks that have literally, yeah, they have not been, they have no clue. So they're waiting, again, they're running to failure, which is very expensive. Okay, thank you, everybody.